We present MIRIA, a mixed reality toolkit for the in-situ visualization and analysis of spatio-temporal interaction data. With MIRIA, we aim to support HCI research in the fields of mixed reality and multi-display environments. We provide the tools necessary for the visual analysis of typical study data such as movements of users or tracked devices, interaction events, and videos. The core of our concept is to enable the co-located analysis by multiple users directly in the original environment. We provide 3D trajectories of locked tracking time series. Virtual 3D objects indicate the position and orientation of the tracked users or devices. Additional 2D view containers can be placed freely and show visualizations such as heat maps or scatter plots. These 2D visualizations can also be combined. Finally, 2D views can also show videos or a timeline, and may even be attached to physical objects. In our current prototype, we support importing tracking data from CSV files. An XML config file describes the metadata of the study and the analysis session. After loading the data, the analyst can set the scene's origin according to the originally used coordinate system. Our prototype runs completely on Microsoft's HoloLens. No further instrumentation is needed. Situated 2D panels provide info about the study data, allow users to switch between sessions or conditions, and are used to create visualizations. A playback panel can be used to navigate through the time series and start or stop automatic playback. We also support time-based filtering of the data. The playback panel can also show events on a timeline. The current implementation of MIRIA supports several types of visualizations. Most importantly, we support 3D trajectories, showing the 3D movement of one or more tracked objects or users over time. Instead of a user-defined object color, they can also be configured to show color-encoded local speed. In addition, we also provide a 3D trail view, showing only part of the trajectories and reducing visual clutter. We also support a range of 2D views that can be placed arbitrarily by the user. In this example, we show an application screenshot as additional context directly at the position of a wall display. In addition, we support visualizing event positions by scatter plots and point plots, shown here in combination with the virtual image overlay. All of our 2D views can be combined and may even be attached to dynamic objects. To demonstrate the usefulness of the MIRIA concept and application, we collected expert feedback in multiple hands-on sessions with data from several existing user studies. Our first example was comparing touch input and the use of spatial interaction for the exploration of 3D visualizations. As can be seen here, the touch condition showed much higher camera speeds in large circles around the data, compared to more dense, localized camera paths during spatial interaction. Our second example was studying user movements in a 4-player game on a large interactive display wall. With MIRIA, it is possible to analyze user interaction in situ, augmenting the game or video footage thereof with spatial interaction data and keeping the rich contextual clues from the real physical environment. For details, please refer to the paper.